That's a good cup of coffee. And it's consistently good. Now, why is it consistently good? Well, particle size analysis allows us to have the same old good old cup of joe every morning without fail. I'll explain how it works, so stick around after I'm done with my coffee break. Hey there, what's up? My name's Andrew Kotlar, and when manufacturing coffee products, ensuring the coffee grounds consumers will purchase is uniform in size is essential to the coffee manufacturer's quality control program. Doing so helps control customer satisfaction, as uniform grounds create a consistent taste with each brew. But as dependable test sieves are the foundation of accurate and repeatable results, what test sieves should I be using? W.S. Tyler has been a top manufacturer of test sieves for over 150 years and is here to provide insight into everything you need to know about designing the perfect stack of test sieves. So in this video, we'll go over how to design the perfect sieve stack, what sieve shaker you should use, and some common sieve errors you should consider when designing a sieve stack. So designing the ideal sieve stack is similar to how you design a sieve stack for other food production operations. When you're starting a new product or developing a new product and trying to calculate your particle size distribution, knowing the general size of the bulk of your material is key. So, for example, if the bulk of your material is 1 millimeter, you'd start with a 1 millimeter test sieve, then go either 1 sieve coarser or 2 sieves coarser, and then a sieve finer or 2 sieves finer. This all depends on how much you want to look at the material split or how much material you think is close to that nominal size. Going more in depth though, if you know the bulk of your material is around 50 mesh, your sieve stack could be 40, 45, 50, 60, 70, and the collection pan. And if you know there's very fine particles in your material, lab technicians can replace the 70 sieve with a 200 sieve. But whatever your coffee production process looks like, the concept of designing a sieve stack in step increments yields the most accurate distribution curve. Coffee has the tendency to become oily, especially when freshly ground. Because of that, the standard W.S. Tyler RX29 sieve shaker will deliver the best results in most cases. This is because the 8-inch sieves that are fitted into the row tap are perfect for fairly coarse particles that are tested during coffee production. Additionally, the mechanical tapping motion will break up any material stuck together from the residual oil that is present. As with any test sieve analysis, you have to make sure you're not overloading the sieve with material. Gathering the correct sample size requires you to consider the sieve diameter because it controls the sample's ability to find the mesh openings during the sieving process. So when working with coffee, you'll want to ensure your material is dry. Otherwise, like I said before, the coffee is often oily, which can cause agglomeration and skew your results. You'll also want to do an end of sieve analysis. You'll want to conduct several tests using the sample coffee grounds and the same sieve stack for coffee production. If your results skew a little bit, you can adjust your sieving process by either taking a sieve out or placing additional sieves in the stack. And when you're done conducting a test sieve analysis, all material that was tested should be properly disposed of. Thanks so much for watching. If you have any questions, fill out a contact us form so we can answer your specific questions. Just click the link in the description. And if you'd like to learn more about woven wire mesh or our many products, we have a learning center filled with written and video content to make you an expert. Just click that second link and you'll be that expert in no time. And don't forget to click the subscribe button and ring that bell to keep up with all things W.S. Tyler. Once again, my name's Andrew Kotlar, and I'll see you around in the next video. Bye for now.